Welcome all of you to the chemistry online classes. So we are discussing about the electromagnetic radiations and how the electromagnetic radiations are generated, how the charged particle is influenced or it produces the electric and magnetic fields, and these two electric and magnetic fields are in the form of the waves, and those are perpendicular to each other and also perpendicular to the direction of the propagation of the wave. Such waves are called as electromagnetic waves. Okay. And then these electromagnetic waves are also called as electromagnetic radiations. And there are several types of the electromagnetic radiations, already I said you, and those vary in their wavelength, frequency, wave number, etc. Okay. The characteristics will be different, and there is an existence of the several type of the electromagnetic radiations. Okay. And then these electromagnetic radiations are arranged in such a way that there will be these electromagnetic radiations are arranged in the increasing order of their wavelength or in the decreasing order of their frequency is called as electromagnetic spectrum. So, see here, the term electromagnetic spectrum is nothing but it is the arrangement of the okay. See here, what is electromagnetic spectrum? It is the spectrum which consisting of the different electromagnetic radiations. Okay. It is the arrangement of the electromagnetic radiations in the increasing order of their wavelength. It means the wavelength is increasing, lambda is increasing, or it is arranged in the decreasing order of frequency. In that range, frequency decreases, wavelength increases. Such a type of the arrangement is called as electromagnetic spectrum. Okay. And see here, suppose this is the spectrum, electromagnetic spectrum, how these electromagnetic radiation, gamma rays, X-ray, UV and visible light, IR, microwaves, radio waves, all these are the arranged, and this is the reason which is the smallest portion of the entire electromagnetic spectrum, that is visible spectrum. Okay. And this visible spectrum consisting of the violet to red color, that is VIBGYOR, this is violet, indigo, blue, like that colors are arranged here, and this is the visible spectrum, and this visible spectrum is the smallest portion in the electromagnetic spectrum. Okay. So, what is electromagnetic spectrum? The arrangement of the different types of the electromagnetic radiations in the increasing order of their wavelength or in the decreasing order of their frequency is called as electromagnetic spectrum. The electromagnetic spectrum consisting of varieties of the electromagnetic radiations like gamma rays, X-ray, UV, visible, IR, microwave, radio waves, etc. And in that the visible spectrum, okay, it consisting of the VIBGYOR, that is violet color, whose and red color, it starts with violet and ends with red, and this visible spectrum is the smallest portion in the entire electromagnetic spectrum. Clear? So, this is regarding the electromagnetic spectrum. So, already we studied about the characteristics of the electromagnetic radiation or wave. So, there we studied regarding the wavelength, wave number, frequency, velocity and amplitude. And here I want to tell you the numericals which are based on those formula. So, first of all, just a quick review of those formula because we are going to use here. So, first the wavelength or wave number nu bar is equals to 1 by lambda, okay. And then the frequency nu is equals to c by lambda, and then the velocity velocity is equals to nu into lambda, So, these are the three formulae which you need to remember in order to solve all these problems, and here there is a one problem and here is also one of the problem, and let us go for this one. So, here calculate the wave number and frequency of the yellow radiation having the wavelength 5800 angstrom. So, what is the question? First, what they have given, write down the points which they have given. Wavelength, that is a lambda they have given 5800 angstrom, and angstrom should be converted in terms of the meter, that is 5800 into 10 to the power minus 10 meter, okay. And then let us go for the what they have asked to calculate the wave number and frequency. This is wave number, and one more thing, they have asked to find out the frequency, okay. They asked to find out the frequency as well as wave number. So, first wave number, nu bar is equals to 1 by lambda. Lambda already we have calculated. So, substitute the value 1 divided by 10 to the power minus 10, okay. Simply wave number formula is 1 divided by lambda. Lambda already they have given, that is wavelength they have given 5800 angstrom, that should be converted in terms of the meter. So, in order to convert into meter, you should multiply it by the 10 to the power minus 10. So, we have substituted the values, and if you calculate this one, you are going to get the answer at around 1.724 into 10 to the power 6 per meter. Okay. If you calculate that, it will be at around 1.724 into 10 to the power 6 per meter is the wave number. Clear? So, let us discuss, they have asked one more thing, that is frequency. Frequency nu is equals to c by lambda. We know that frequency formula is c by lambda. So, what is the value of c? 3 into 10 to the power 8, 3 into 10 to the power 8, and then lambda already we know that. Okay. So, substitute the value of c, that is the velocity 3 into 10 to the power 8, and the value of the lambda, that is which is converted in terms of the meter. So, if you simplify this, it will be around 5.712 into 10 to the power 14 per second, 10 to the power 14 per second. Okay. So, this is how we can calculate the wave number as well as frequency for the yellow radiation, which is having the wavelength 5800 angstrom. So, just keep these three formula in your mind, so you can apply here, and you need to convert which sometimes they will give you nanometer, you should convert that into meters, like that you should go for the conversion. Okay. Let us go for the one more problem, that is here the wavelength range of the visible spectrum, extends from violet to violet, its wavelength is 400 nanometer, to red color, that is 750 nanometer. Express these wavelengths in frequencies, that the value of the unit of the frequency is hertz, or even you can use the per second, and they have given 1 nanometer is equals to 10 to the power minus 9, 10 to the power minus 9 meter. Okay. So, let us go for the one by one. First, for violet color. For violet color, what is the value of the wavelength? Lambda is equals to 400 nanometer. Lambda is equals to 400 nanometer. Nanometer should be converted in terms of the meter. So, 400 into 10 to the power minus 9 meter. This is the conversion of the nanometer wavelength, because they have already mentioned 1 nanometer means 10 to the power minus 9 meter. So, that is 400 into 10 to the power minus 9. Now, what they have asked? Frequency. Frequency nu is equals to C by lambda. We know that C is 3 into 10 to the power 8 and the lambda value is 400 into 10 to the power minus 9. So, if you calculate this, 7.50 into 10 to the power 14 hertz. Okay. So, the value we need to find out the frequency. We have the formula that C by lambda. C value we already know, all the electromagnetic radiations move with the velocity of the light, that is 3 into 10 to the power 8, and then lambda value they have given in terms of the nanometer, we should convert that into the meter. So, 10 to the power minus 9 we have converted in terms of the meter. So, if you simplify this, you are going to get the answer of 7.50 into 10 to the power 14 hertz. Okay, this is for the violet color. Next, one more color we need to find out, that is red. For red color, what is the wavelength they have given? The wavelength they have given is lambda is equals to 750 nanometer. Again, this lambda should also be needed to convert in terms of the meter. So, 750 into 10 to the power minus 9 meter, 10 to the power minus 9 meter. So, what we need to calculate here also? Frequency nu is equals to C by lambda. So, what is the value of C? 3 into 10 to the power 8 divided by lambda value is 750 into 10 to the power minus 9. So, if you look at this answer, means it will be around 4 into 10 to the power 14 hertz. Okay. Simply they have given the wavelength, you need to convert that, or you need to by using that wavelength frequency should be that we should be calculated, and it should be expressed in terms of the hertz. Even sometimes even we can able to express that frequency in terms of the per second. So, unit is very important in every problem, because if you are not going to mention the unit, means you are going to lose the 1 mark. So, compulsory you should mention the whatever the unit of the given frequency or wave number what they have asked, according to that term you should use the particular unit. So, this is how we can explain about the electromagnetic spectrum. The definition is important and this visible region is important. And then here problems, you need to remember these 3 formulae which are very useful while solving these numericals. I hope so these 2 problems are clear for you, and further few more problems we will continue in our next class. Until that, note down the points and try to solve few more examples. Thank you. Let us discuss few more problems. Okay. So, here calculate the frequency of the radiation in hertz having the wavelength of 600 nanometer. It means they have given the wavelength. So, what is given? Wavelength lambda is equals to 600 nanometer. Okay. The nanometer should be converted in terms of the meter, that is 600 into 10 to the power minus 9 meter. And what we need to calculate? We need to calculate the frequency. Frequency nu is equals to C by lambda. So, what is the value of C? 3 into 10 to the power 8. Okay. And lambda already we have converted in terms of the meter. Okay. So, this is the value of C and this is the value of the lambda. So, if you simplified this, it will be around 5 into 10 to the power 14 hertz. Simple. What they have given? They have given the lambda, that you should convert in terms of the meter, and the question we need to find out the frequency, and we have the formula frequency nu is equals to C by lambda. So, substitute the value of C and substitute the value of the lambda. So, you are going to get the answer 5 into 10 to the power 14 hertz. If you simplify this, you are going to get this answer. Okay. I hope so it is clear. So, next, here a molecule absorbs a frequency of 1.5 into 10 to the power 15 hertz. Calculate the wavelength. Reverse. Here they have given the wavelength and they asked you to find out the frequency, and here they have given the frequency and they asked you to calculate the wavelength. So, the frequency nu is equals to 1.5 into 10 to the power 15. So, we have the formula in order to find out the wavelength. Lambda is equals to wavelength, lambda term you separate out, lambda is equals to C by nu, lambda is equals to C by nu. C value already know, 3 into 10 to the power 8, the value of the C is same. Okay, that is 3 into 10 to the power 8, and the value of the nu is 1.5 into 10 to the power 15. So, no need to calculate, it is all, no need to convert, because it is already given in terms of the hertz. So, if you simplify this, you are going to get 2 into 10 to the power minus 7 meter. Okay. So, in order to convert this wavelength in terms of the meter nanometer, I will make this 200 into 10 to the power minus 9. 200 into 10 to the power minus 9. This is nothing but 200 nanometer. 200 nanometer. Even the meter can be converted into nanometer. Okay. So, this is how we can able to find out the wavelength when they have given frequency, and this is how we can able to find out the frequency when they have given the wavelength. So, next, calculate the wave number of the radiation having the wavelength 500 nanometer. So, here the question is we need to find out the wave number, we need to find out the wave number. So, what is given? Wavelength, that is lambda 500 nanometer, that should be converted in terms of the meter, 500 into 10 to the power minus 9 meter, and we need to calculate wave number. Okay. And the wave number nu bar is equals to, you know, it is reciprocal of the wavelength, it is the reciprocal of the wavelength. So, 1 by lambda, nu bar is equals to 1 by lambda. So, keep 1 as it is and substitute the value of the lambda. So, value of the lambda is 500 into 10 to the power minus 9. So, if you calculate this, you are going to get 2 into 10 to the power minus 6 per meter. Unit of the wave number is per meter. Okay. So, this is how we can able to find out the wave number when they have given the wavelength. Clear? So, next here calculate the frequency of the radiation having wave number. It means they have given the wave number, that is 5 into 10 to the power 6 per meter. We need to find out the frequency. So, we know that given is wave number nu bar, that is 5 into 10 to the power 6 per meter. This is the nu bar. We need to calculate nu. Okay. So, here we know that frequency is equals to C by lambda. Frequency is equals to C by lambda. It is nothing but 1 by lambda. What we can able to write it as wave number nu bar. Yes or no? 1 by lambda. Wave number is 1 by lambda. So, 1 by lambda I will take it as a wave number, that nu bar I am going to represent, and C is the velocity, as you know. Now, you can substitute the value. The value of the C is 3 into 10 to the power 8, and then value of the nu bar. Directly it is this formula you need to convert, that is 1 by lambda you need to convert in terms of the wave number. So, now you can substitute the value of the wave number. Okay. So, I have substituted the value of this wave number. You will get an answer around 1.5 into 10 to the power 15 hertz, 1.5 into 10 to the power 15 hertz. Here they have given the wave number and they said you to calculate the frequency. We know that frequency is equals to C by lambda, and that 1 by lambda we can able to substitute as wave number nu bar, and already we have the wave number value and C value. Just you multiply these two, you are going to get an answer of 1.5 into 10 to the power 15 hertz. Clear? So, let us go for the one more problem. Calculate the frequency and the wave number. Frequency and wave number for the radiation of wavelength 530 nanometer. So, here what is given? Wavelength 530 nanometer, that is 530 into 10 to the power minus 9 meter. So, we need to calculate frequency. Nu is equals to C by lambda. So, what is the value of C? 3 into 10 to the power 8 divided by lambda value is 530 into 10 to the power minus 9. So, this is the value of the C is constant in everywhere, and lambda we have converted nanometer to meter and we have substituted. So, what will be the answer? It is 5.66 into 10 to the power 14 hertz, if you not hertz, per second, frequency per second, or even you can use hertz, no problem. Frequency, its unit is also expressed in terms of the hertz. Okay. And this is how we can calculate the frequency. And one more thing, they have asked you to find out the wave number. So, the wave number nu bar is equals to 1 by lambda. So, 1 by lambda, lambda already we have, only the thing you need to substitute. So, if you calculate, it will be around 1.88 into 10 to the power 6 per meter. Okay. So, in all these problems we are going to use only three formula, that is nu bar is equals to nu is equals to C by lambda, one formula, nu bar is equals to 1 by lambda, and then C is equals to nu into lambda. Only these three formulas are very important, and just you write down whatever they have given first. and convert them, if it is necessary, convert them into meters and whatever conversion is there, and then you write down what you need to calculate, and the relevant formula you should enter and substitute the values which are given correctly and simplify it and write your answer with the unit, because the unit carries the 1 mark. So, the unit of the frequency you can express in terms of the hertz, or you can express in terms of the per second. And then wavelength means meter or nanometer, and then wave number is per meter, as you know already. So, this is how we can able to solve few of the example which are used to calculate the frequency, wavelength, wave number, etc. So, in our next class we will go with one more important theoretical concept. Until that, keep watching the video. If you have any doubts, you can contact me. Just you go through the video one more time, so you can able to understand each problem clearly. Thank you.